Hello everyone, welcome again in a tutorial video for naive bias classifier. In this tutorial, we will focus on bias classification based on a work of probability. So first we have to find the probability statement. Here we have a given of features B1, B2 to Bn, means the features represent the independent variables, the features of the products or processes, or maybe if you would like to find data from your customers through marketing research, that features of your services can be represented by B1, B2, and Bn. And predict label A is a dependent variable. Here we can see the expectation of our customers can be yes or no, and maybe satisfied or dissatisfied, can be like that. And here we have to find the conditional probability of A given the features B1 to Bn. So it is the multiplication of the conditional probability of B1 to Bn given A times probability of A divided by the probability joint probability of B1 to Bn. So because this is the only equation used in a naive Bayes classifier, therefore there are specific feature of this kind of classifier is that the assumption that each of these independent variables are really independent, so they do not consider about the joint probability between B1 and B2 or B1 and B3 and or maybe B2 and Bn. So we assume that those features are totally independent one of another. And yeah, if we like to find the similarities between artificial neural networks and this kind of feature, is that the x1 and x2 here is quite similar to our feature here, b1 and b2, and the weight, as we have studied in a course about support vector machines, is represented by the probability. So x1 and x2 is the feature, and w1 to w2 is the feature. Therefore, now we have to find what is the value of the y. All right. So according to this artificial neural networks, we have to find some kind like classifier that can minimize the expectation of y and the real prediction. So finally, we have to train the classifier. Here, the training consists of several data that can be split into two parts: the training data and also the validation data. And yeah, the joint probability of x1 to xn given y here, x1 to xn given y, is equal to the capital Pi of conditional probability x1 given y from I to 1 to n. So here, what is capital Pi? It is some kind like the multiplication of conditional probability of x given I from 1 to n. So we will discuss the validity of this assumption later. And there are three types of distributions here. We have a Gaussian distribution, multinomial, and Bernoulli. And the Gaussian distribution, we assume that the features are continuous. Therefore, the assumption is the normal distribution. So, for instance, in this case, if we have numerical features, some kind like a dimensional features of products like length, area, maybe or height. But the multinomial, it is useful for if your features are discrete or non-numerical. For instance, if you would like to differentiate a product between yes or no, based on some kind of discrete feature, for example, like red or color, red, green, yellow, and maybe hot and cold, for example. That's you should use a multinomial distribution. And Bernoulli, it is only binary model. So your features consist of only two types. It is, for instance, yes or no, maybe black and white, or maybe agree or disagree. So there are three types of distribution can be used in naive Bayes classifier. Okay, now we can continue to our exercise. We have naive plus Bayes classification for numerical data set. So you should open file, Python data files. Here also you need to open the Anaconda software, and the task is that to count the mean, standard deviation, and variance of its independent variables, and then you have to measure the prediction accuracy of the naive Bayes classifier for the data. So it is very simple. Okay, just ignore this. It is later. For exercise 4, we will consider classify red domestic SUV vehicles. But okay, now we have to open first the Python data file bayes.py. All right. Sorry, I made mistake. It's not .py, but it should be .csv because it is the data. It's not the file. So all right. Now I can start to make a program in Python. First, we have to import the library. We have to use random because we will use randomize or maybe some kind of random variables to pick the features in our table. And then we need to use also map here, and we have to import also numpy as np. Here we have to find the path where we need to get the data. I think you have already got it from the previous video. The data is from Python data. Sorry, what is the problem tell about Python data file Bayes data file Bayes dot csv, and the data set here is equal to numpy dot get from text, get what is get, yes, get from text, and path, because the target is path 1, and we have delimiter. It is how to recognize a data. It is separated by comma, and then skip the header. So we have to skip header and equal to 1, and then filling value. If it is there is some kind like non-assigned cells, we have to put number 999, so that it will be ignored by the Python. And then the d type, it is like data type equal to float because it is numeric, and the use columns it's equal to we have 8 column here, 1 2 3 4 5 6 7. All right, and here we have 8 column, 1 2 3 4 5 6 7. Sorry, 7, but we have a rotate here. All right, and split ratio is equal to 0.67, means that the percent are for training and 33% for validation. And then we have to put here the data set x equal to, all right, so we have to put here the data set, comma, -1 means -1 means the last column. So before the last column before the last columns are column for independent variables. So here we have y data set -1 means the last column is data for the dependent variables, and we have to find now. We have to define our equation for data set. All right, so we have here data set comma split ratio, and with semicolon. We have to find or to design how much the train size or the data for training it is taken from the data set. Int length means along the length of data set. We took the integer value, means the integer is the counter of the number of the rows, and we have to multiply with split ratio here. What's wrong here? What happened? Why this? Yeah, okay. Split ratio data set. Oh, I think we put more. Okay. Now we have train set. In order to quantify the train set, it is readable by NumPy. Therefore, we have to put this some kind of bracket, and we have to copy the value from the train set by listing the values data set. And now we have to put conditional that while the length of the train set is less than something. Where is less here? Okay, here less than train size. Then we have to put index. The index, because we pick randomly, we rearrange the data set for training, so that row number 1 maybe can be still number 1, but can be also number 5 or number 6. So it is some kind of shuffling that again to make the data more to be more distributed more normally, and range and the length of the copy. Right, and then we have to put train set dot append. Yes, append here at the beginning. Then we have to put here copy dot pop population. We have to populate the data within the new organized data, and we can take the values by returning the values into train set, but we took the new values into copy, right? So now we have to find this define the second function. It is separated by class. By class. Here we have to separate the data, and we have to make some character like the dictionary. So our data will be separated between between according to different outcomes of dependent variables. Here we have -1 and 1, so therefore we have to split into two, which group according to -1 and which group according to +1. So here we have for I, okay, in range when dataset, and then separated. All right, this dot, sorry, this will be, yeah, we have to put the factorization of the data. Factorization means after we split into two groups, class +1 and -1, we have to differentiate those two groups into factor. Here we have the factor data set I, and then we have to make a conditional here if the factor of -1. Now we are working with one group. It is called -1, not in separated. Okay, it should be. Then separated factor -1 equal to, yeah, equal to the this a bracket mean so if for instance the factor of this -1 mean the factor of the n or the dependent variables not in separated, then it is the separated factor of -1 means this factor that's in the factor of the last column in the table, it is equal to 0, means it is not be included into the computation. For instance, if we have here -2, for instance, it is not within -1 and 1. Oh, sorry. The equation means that if the factor -1 not in separated means yeah. So for instance here, if the factor -1 not in separated means if it is not in the data set for training, then the separated factor -1 it is put into this bracket, means should be in train set. So for instance here we have, for instance, this number 13 or number 12, it is not included into this group separation, then it should be put into the group not for training but for checking or for validation. Here that's what the meaning of this syntax. And now we have to put this separated factor -1 dot append mean appendix. So it means we have to construct row by row in separated factor, means we have to reconstruct those two groups and do it for and we have to put another index because if for instance here -1, this is the first -1, in this will be the first +1. So in the original it is the second row, but after the regrouping and separating into two different groups, it can be the first row in +1 group. All right, now we have to copy and yeah, append copy and dot populated. We have to populate again and make it and give the data and the new index, and we have to return. Sorry if I made, yes, and then we have to return separated. All right, yes, yeah. All right. Okay, now we can calculate to define our mean values, mean for each rows in input group +1 and -1. So we have a new definition or new variables. It's called numbers, and in numbers we have to return sum of the numbers and divided by the length of the columns. So how many rows within each column. All right, so now we have defined our mean, and we have to define also our standard deviation. All right, so here also number, and okay, let's call it AVG, average, equal to mean of the numbers, and all right, AVG equal to means of yes, and variance, we have to find the variance. For the variance equal to sum of power, yeah, the power means the power, x the power of something. Oh no, so I have to find this power x minus avg and the power of 2, and yeah, we have for x in numbers. Yeah, wait a second, I think we need to put more. Yes, sum of the power. Okay, I think we have to use this one instead of bracket. We have to put, yeah, x in numbers, again divided by float and length of the numbers -1. So it is the equation for counting standard deviation. So x minus the average of the value of in the such a column, and then the square of the value x minus the average, and we have to sum those computation and divide it by the number of the data within such a column -1. So that's can be found in all statistic or statistic books. that you have. You can find also in the internet. Okay, let's say for instance you have, yeah, you can standard deviation here formula. Okay, right? So we can find, yeah, so x minus average square root, and then we have to sum this value divided by n, right? So the problem is that why we should consider about n minus 1 here, right? It is n minus 1 because it is the standard deviation of the groups, not the entire population. So if it is divided by n, it is considered the standard deviation of the total population. For each groups, we have to use minus 1 after the number of the data. All right, so we have to summarize the data by putting here define the, yes, and then summarize, and data set, that summary is equal to, we have to, so we summarize everything we have count, for instance mean and standard deviation, and also as well as the variance. So we can put here mean attribute. Attributes mean the feature that we would like to count. So attribute, and standard deviation of the attribute. So attribute means here x1 is attribute number 1, x2 attribute number 2, x3 attribute number 3, and so on. And all right, so we have to find this attribute for, yeah, attribute in zip. Zip means we collide all of those x from x1 to x6 within the data set. Right, so we can put here, so we have, okay, so no, this is not, yeah, this one. All right, wait a second, attribute, yes, min attribute, deviation attribute. Okay, so we have to use this bracket instead of, yeah, all right. Yeah, what else? So we have to, yeah, because we would like to summarize only the x value or independent variables value. That's why we have to delete the summary for the dependent variables. So it is minus 1. So if you mention minus 1, means it is the end of the end column within a table. That's the rule, or maybe something like yeah, code for NumPy. If it is minus 2, means the second column before the last. So we have to return the summary. All right, okay, yes. Now we have to summarize by class. So the previous summary, it's a summary of the entire independent variables, regardless it is considered as a group plus 1 or minus 1. Now we have to summarize the variable by class. So there will be summary for plus 1 and summary for minus 1. Okay, so also according to the variables, it is data set. And yeah, do not forget to put, and then we have to put here separated, sorry, we have to, all right, separated equal to separated by class, we have to put as a variable. The data set is the data set as the variable. All right. All right. Maybe you will ask, what is the difference between this kind of bracket and this kind of what is it? It is called what is it? I try to find a good, yeah, this kind of parenthesis and this kind of bracket. In parenthesis means you do not have the exact values, what kind of value you have to put inside. But by using this kind of bracket, you require that the Python or the NumPy will produce some kind of data. For instance, here the mean of the attribute is only single value, mean, how much the value of the mean or standard deviation. But here data set, it is a set of data that have so many values, so you do not expect that the NumPy would issue or will produce exact, for example, a certain values of data. You just put it here with parentheses, means I will use this class, separate by class, according to variables of data set, regardless it is data number 1, number 2, or number 3, but it is within the group of data set. So here we have to after we summary by classes, again we have to put into dictionary the summaries equal to dictionary. Yes. So we separated by class the data by looking at the dictionary of the summary. So we have here the summary, and we look the summary in this function summarized by class as a dictionary. So we will not go into other summary unless we change. It is not a summary, but maybe other definition. So now we have to for class value, that instances in separated of the items with these parentheses, we have to summarize the class value, according to the summarize the instances. All right, and we have to return the summary. Yeah. The code saying that for class value means whether the +1 or -1. The instances in the separated, we know that in separated means the data used for training for each items, and we have to make the summary by classes. So after we separate the data into their own classes, +1 or -1, and then we have to make a summary. So this summary consists, there are two summary here, summary for +1 and summary for -1. So in the output of this Python, there will be two different matrices. The first metric for class 1 or +1, class +1 or -1, and the second metric for class -1. So the output will be all kind of data uh, from the original variable, but already been split it into two classes. The first class is a plus one class, and the second class is minus one class. All right. After we make the summarization by classes, the next step is to count the probability. First, we have to calculate the individual probability. Means for its not its features, but for its rows, we have to calculate how much the probability of that feature, certain features occur. Then we can write like this: calculate probability. So because this is an individual probability, and therefore we have to include its cells within the table for its cells, its classes, and independent variables. So we have x, comma mean, comma standard deviation, because formula for calculating the probability needs these three variables: x, mean, and standard deviation. First, we have to find the exponent of the equation for probability. Okay, the exponent is equal to math.txt because we are using math library, and then minus exponent of minus we have math also here, the power x minus mean, and then comma 2, and times math dot power. Oh, sorry, because we are using math instead of numpy, then we write only POW or power. You have to be stick with the rule of its library. For instance, if you are using numpy, for instance here you are using numpy, but instead of math, then you need to write power instead of power. And we have to close. How many? All right, is it? Yeah, exponent something. Okay, we need to check. All right, now we have calculated the exponent. The exponent actually is nothing but the z-score of normal probability. So the z-score equation is defined as a ratio between x minus mean divided by standard deviation. So the exponent is the square of the z-score. After we calculate the z-score, we have to calculate the probability. Usually in statistics, you use the z-score and find from the z table to find the probability. But here in Python or in programming, in coding, we try to avoid to use the z table in statistic books. Rather, we now trying to make a new formulation to replace the table by using this kind of formulation. Yes, 2 times math dot pi, this is pi 3.14, and times standard deviation, and times 1. Okay, so we have to like this. Yes, there are two parentheses and times x owner that we have already defined as a z-score, the square of the z-score. Yeah, so now we get our probability, that is individual probability for each value within each cells in our table. And after we calculate the probability of each cells, means its values of the independent variables, now we need to find also the probability of each class. So here we now start calculating probability of y equal to +1 and y equal to -1. So we again define a new function, call it calculate class probabilities by taking two variables from summary and from the input vector. Yeah, input vector is a vector of the rows of the independent variable. So here we have two input from summarize. Summarize is the summarize by class. We already got the value from summarize by class function. And input vector, vector is the variables coming from our independent variables x. So we already calculate our individual probabilities, and therefore now we can create a new library that contains the value of individual probabilities. And now we can calculate that for class value plus or minus 1, we have a class summary in summarize, okay. Summarize. Yeah, summarize, right? Yeah. We here in summarize. Yeah, it is not summarizes, but summarize. Yeah, now we have summarize in summarize, and dot item. What is dot item? It is nothing but we try to make iteration for each rows depending on the classes of the rows. Can be +1, can be -1. And probability of the class value. Because the class value already defined plus or -1, then we should use this bracket. It is equal to 1. So this statement mentioning us that for class value where class summarize in summarize.items, so for if we already when we have already summarized the class value into +1 or -1, that the probability of the class value always 1, because it is already stated in the previous function of summarize by class. And then we have to find the mean and standard deviation for each classes. So here for y equal to +1 and y equal to -1. So yeah, for I, it is in range of length class summaries. Then mean and standard deviation equal to class summaries I. And what is, we have to define what is the class summaries I. So we have x equal to input factor of I. Yeah, because we need to calculate the class probabilities for +1 and -1 with the input factor coming from the independent variable x, and therefore the input factors has I number of inputs coming from the independent variables. So we can calculate here the probabilities of the class value, and then we have to put this bracket considering that the number or the value of the probabilities can be extracted from the function. So we calculate here class value star equal. Star equal means for items within the within each column should be multiplied in order to get the probabilities of the class value. So it is actually the equation for capital Pi. So here I think we can show you the origin of this probability function. All right, now we can see in our screen that we have the naive Bayes assumption that this capital Pi of xi given y within this capital Pi means for each I of the feature x, we should multiply as many as the number of I in order to get the probability of all xi from 1 to n given y. So here it is stated in Python by using star equal to. So here we have a calculate probability and x, comma mean, comma STDEV, standard deviation, which return the values of the probabilities. All right. Yeah, after calculating the probability or class probability, I think overall we have already counted anything and included anything of items or computation necessary to make a prediction. And therefore the next step is that we need to define a function to make a prediction of the value of the y of the independent variable based on certain value of the feature. Here we define a new function predict, and we have two variables here, summaries and input factor. And first we have to input again the probabilities. The probabilities equal to calculate class probabilities as a function of summaries, comma input vector, and now we need to define which one the best. That's why best mean because we have to calculate the probability of the combination of several features. It will close to +1 or close to -1, where the best means any combination which result in the highest probability goes to either +1 or -1. So we are here to write about best level, comma best probability. It is equal to none, because we do not count yet how much the best probability, and therefore we calculate as we write as a none. And in the last column, the probability of y equal to +1 or -1, because we do not count yet, and therefore we write none in the first guess of our prediction. And then for class value, probability in probabilities dot items now we are trying to get the value which closer where it is closer to +1 or closer to -1, and therefore we have if best level is none, or the probability is higher, way higher, higher than best probability, then best prop equal to the probability, and best level equal to class value. All right, I can explain about this last 5 lines. Here we have best level, comma best prop equal to none for the last column, -1. Means at first we do not have any decision whether the class, whether a certain row that we would like to predict it is +1 or -1. It is yes or no, or maybe it is black or white. We still in the stage that we start to make a prediction, and therefore we write as none. And therefore now after we start to make the first stage of prediction, and then we start making class probability calculation here. And therefore for class value, if the probability within probabilities in items, means if the class value is there, means if the class value it is +1 or -1, after calculated by using this join probability function here, if best level, So the result of these probabilities is the best level. If best level is none, means if it is the first calculation, or if it is has probability and the value of the probability is higher than best probability, means after the first state and you try to make another stage to compare between your first stage, that is none, with the next calculation. If you have for instance the second state calculation, your probability is better or higher than your best probability in the first state of calculation, then the highest probability is taken as your best prob. And therefore, by using that value, you can calculate whether this you can categorize whether the level including in the class value is +1 or -1. And after we make the prediction, we have to return the value of the prediction. Return it is best level. So only the highest probability should be returned or should be quantified and should make a decision, should be used to make a decision whether a certain row is +1 or -1. Now we have to write after we got the value of the prediction, we need to extract the value by defining another function. It is def get prediction. The variables are summaries and set. The prediction is quantified, and therefore we have here the bracket. And then for I, in range of length, the test set then we can extract the result. The result equal to predict by considering the summarize and a set of feature I. So the result will not contain the training set, but only the test sets. After we got the result, we need to append, means we need to make some kind of like tabulation of the result. And moving from one row to other rows in the table. But it is only for that set and excluding the training set. Yes, I think you need to put for I. And we need to return the value here, prediction. Similarly, we need to get the accuracy of about the prediction. How much percent of the test is equal or maybe has been correctly predict the result. And here we have a correct, it is calculated, it is equal to 1. Same, we can copy here for I. And then if that set of I of the that set of feature I, it is equal to the prediction. So we try to compare between our prediction and the original data in the test set. Then correct equal to plus. Okay, now the question is that plus equal to what? Now the question is that why we have the first value of correct equal to 1 rather than 0. But here we have correct, it is plus equal to 1. So if the last row, the last lines mentioning that we try to count how many correct answer by comparing test set and prediction. So now the question is that why we start the correct value not from 0 but it is from plus 1. Maybe you could try to find a good answer or write the correct answer why we should start from 1 rather than 0. Float and then len test set. Yeah, this time 100. So we try to return as a percentage. That's why we try to make ratio between correct and the total number of data, and then multiply by 100. Now we need to print the result of the prediction and also the accuracy. We can get the data from training set and then test sets. It is equal to split data set by taking variable of data set and split ratio. And we need also summaries. Summarize by class. We're taking data from training set. And prediction, it is equal to get prediction summaries comma test set, and we can print prediction is equal to comma prediction. And we can run this the order, make an order for this function by ending the function by typing pred with the parenthesis. Similarly, for accuracy, we can do the same. Indeed, we need to write here. Oh, sorry, I think we have here predictions instead of prediction, and then accuracy. This here get accuracy. Summary the set, and this here get accuracy. Sorry, get accuracy. Sorry, accuracy. Yes. Get prediction. Get accuracy. Now we can end this function by writing accuracy. Accuracy. All right. Now we have everything within the code. This is quite long code, but the goal of why I choose this code is that, of course, you can use like sklearn. It is very convenient. But why I guide you line by line and writing this long coding, because this code is quite convenient, and you can understand step by step in making classification by using naive Bayes classification. Now we can start to run this code and see what happened. Oh, now we have an error here, split ratio. Oh, okay. I think we made a mistake that we should not make a. Yeah, I think now we have a correct answer. That split ratio should not has some kind like a space between split and ratio. And now we can try to run again. Okay, we have another error, which, okay, line 43. Oh, yes. We have here define function without return. So I think we need to add the return for the standard deviation. So it is the return. Yeah, I forgot to write the return here. Met square root of the variance. That's the equation for the standard deviation. So yeah, now we have another error. Maths, and what is the invalid syntax? Okay, let's see. Variance is equal to sum of pow x minus avg square for x in numbers. Yeah. Now I remember. I think we should put here one, here also one, because this is the value that should not be separated. And float, and yeah, I think it's missing, right? And okay, now we can start to run. Wow, we have another syntax error. What is that? It's okay, 57. What is 57? All right, so let's check 57. Calculate probability. All right, exponent. Oh yeah. Now we can see that we have lack of. Okay. Yes. Okay, let's see. Math exponent. Yeah, math. Oh, exactly. We should put here another map. Yeah, just to tell that this value is a single value, and we have to put here, sorry, exponent. Yeah, divided by, yes, yeah, 2 times, yeah, math power. Is it correct? We okay. Okay, we can start to run model. Okay, now we have another error, line 81. Okay, we should prediction, and for I, yes, get prediction for I in range length and test set. What is okay? Yeah, that's stupid. We have to put here for every operation related to function and conditional, you have to put double dot at the end of the statement. Okay, I hope now we don't have any more error. Okay, that one not defined. Which one is? Oh yeah, I should put here pet, not instead of pet. Okay. Okay, let's start to run this. Oh yeah, filling values, because we will have many values in the table. Okay, let's start again. Split dataset is not defined. All right. So what happened with, yeah, this function actually use split dataset instead of using uh, small s. We have to okay, split dataset, and with, sorry, 94. We have to use a small split, yes, this one, because we don't have a split dataset function with capital S, so we have to use a split dataset without capital S. All right, so what is the get prediction? Get prediction. So you have to be careful in Python that between capital and non-capital letter is really matter. Same as if you want to code in C or C++, or even maybe in Java also. I hope we don't have any more. Okay, we still have split data set. Yes, we should not use capital S here. Is it? Train set. Okay, train set. Let's see. With train set, line 22. Okay, train set less than. All right, so yeah, now we have, so be careful with capital letter and non-capital letter. What else? Train size. Again, train size. Okay, where is train size? Line 22. Okay, I think this should be using capital instead of we should create, because it makes some confusion. Okay. Yeah, with page 24, train set again, line 25. Yes, separated by class 50. Yeah, by class B and C and capital letter. So what happened here? Separated equal to separated by class. All right. It's not defined. All right. Separated by class. Take by class. Copy. Which one copy here? Line 33. All right. Oh, so we don't have copy here. Yeah, okay, let's see. Oh, no, it is not. Yeah, it is true. It should be a append of the factor, not the copy, because here we have defined the factor, so that's why we have to append the factor instead of the copy. All right, now we still have undefined summaries. What is the problem here? Let's see. Summaries by class. Summaries by class. Return. Wait a second. All right, I think we have, oh yeah, summaries with double M and single R. Yes, class summaries should be capital. Class summaries, yes. Hope now everything is okay. Pow expected 2 argument, got 1. Okay, let's see. Line 57. All right, we have pow. Okay, let's see what is the problem here. Okay, now yeah, we have the problem here. X minus min, it should not be within the parenthesis, but here we have to add one more. All right. Okay, now let's check for the calculate probability. As you can see here that this denominator has a chance to get division by 0, and we need to add here maybe very small number, maybe like this, to avoid the result will return division by 0. And yes, here we can push plus 0.0001. Again, we need to check. Okay. Yeah, we have now a bit problem here. For instance, if test set I equal to prediction, it is wrong because we need to compare between the y of the original data and y of the prediction. So test set I, it is at the last column, equal to predictions, then the correct number should be plus 1. So we need to give this minus 1 as an additional information that we need to compare between the prediction of original y and the calculated y. All right, I think now we don't have any more problem with this code, I hope. And now we can start to make a test. Yes. Okay. Yeah, this is the prediction of the y from 1/3 of the data as a tester, and we have 56.81% of accuracy. It is not a really good result, but yeah, this is what we get. In order to improve the result, we can add more trainer data into our table, so that we can get more experience. We give more experience to our classifier to make a good classification. Okay, so far this is what we can have during this tutorial. and welcome to the next tutorial in not in random forest classification. Okay.